This is 3.5, the Unit 3 practice sheet. In the first section, it says for each function, find the indicated values. So we're given this equation, h of t equals 2t minus 5. And the first one we're going to evaluate is h of negative 4. So what you should see and notice is that h of t became h of negative 4, which means the t value is going to be negative 4. So when you plug back into this expression, we have 2, t is negative 4, minus 5. So 2 times negative 4 minus 5 is negative 13. So the next one, h of t equals 23. So in this one, we're actually replacing h of t with 23. So when we plug this in, we have 23 equals 2t minus 5, and then we solve for t. So the first thing you do is add 5 to both sides of the equation, and we're left with 28 equals 2t. So when you divide by 2 to isolate the t, we're left with 14. 28 divided by 2 is 14. On this one, we are back to h of 13. So inside the parentheses was our t value, so this means that our t value is 13. So when we plug it back into the expression, we have 2, t is 13, minus 5, and that gives us 21. The next one, h of t equals. So again, we're replacing that y value, that h of t, with a negative 33. So we have negative 33 equals 2t minus 5. So just like we did before, we're going to add 5 to both sides. And now we're left with negative 28 equals 2t. And when you divide that by 2 to isolate the t, you're left with negative 14. On the next section, we're using a graph in order to interpret these values in function notation. So we have g of 2. So inside the parentheses is your input values. So we go to our x-axis at 2, and we trace it up to our line, which is at approximately 7. So we're going to put our 7 right here. So our next one says g of x equals 3. So outside the parentheses is your output value. So we go to 3 on the y-axis, trace it over to our line, and down to find the x value of 1. Last but not least, g of 0. Inside is your input, so this means x equals 0. So our y value is 1. On the next one, we have r of negative 1. So again, in the parentheses is your input values, which are your x's. So we go to negative 1 on the x-axis and trace it up to your line. We find out that it's at 10, somewhere around 10. So on our next one, it says r of x equals 4. So that's like saying your y value is 4 because it's outside of the parentheses. So we go to the y value of 4, trace it over to your line and down. And the x value that corresponds with it is 1. Last one, it says r of 2. Inside the parentheses is your input value. So we go to 2 on the x-axis and trace it up to find a y value of 1 corresponds with it. In our next section, it says, given the following equations, perform the operations that are required. So this has multiple steps. The first thing this one says for letter A, it says f of negative 1. So the first thing we're going to do is we're going to take this equation, f of x equals 4x minus 1, and we're going to plug in a negative 1 for x. So we have 4 plug in -1 for x minus 1. When we evaluate that, we get -5. And then we have j of 2. So we're going to find our equation that has j, and it's this one on the end. And inside the parentheses is a 2, so we're plugging in a 2. So we have -3, x is 2, plus 5. -3 times 2 is -6, plus 5 is -1. So the last step is that they want us adding these two values. So -5 plus -1 is -6. So on our next one, we're visiting the f function again. So this time we have an x value of 0. So we have 4 times 0 minus 1. So 4 times 0 is 0, -1 is -1. So then we have h of 0. So we're going to find our h equation, and it says h of x equals -3. So if we plug in a 0 for x, we still get out a y value of -3. Now, according to our problem, we are subtracting these two. So -1 minus -3. When you subtract a negative, you're actually adding, so this makes 2. The next one says j of x equals -4. So this is that equation. And remember, j of x is the same thing as your y values. So I'm going to replace this j of x on the left side with a -4. And then I'm going to solve for x to find out what does x equal. So we subtract 5 from both sides. We're left with -9 equals -3x. Divide by -3 on both sides. And x equals 3. In our next section, it has f of x plus j of x. So there's no evaluating we have to do first. It's just f of x, which is 4x minus 1, plus j of x, which is -3x plus 5. And at this point, we can combine our like terms. So because there's a plus outside the parentheses don't really matter, but when you get into subtraction, it will. So we're going to bring down our 4x minus 1, positive implied 1. So positive 1 times -3x is -3x. Positive 1 times positive 5 is 5. So when we combine our like terms, we have 4x and -3x, which equals 1x. And then we have -1 plus 5, which is positive 4. So this is the result of f of x plus j of x, is x plus 4. So the next one, we have j of x minus f of x. So j of x, again, is represented by -3x plus 5. And we are subtracting f of x, which is represented by 4x minus 1. So you have to distribute to get rid of your parentheses. So we have -3x plus 5 gets brought down. And then we have that implied -1 outside. So -1 times 4x is -4x. And -1 times -1 is positive 1. So now you can combine your like terms of -3x and -4x makes -7x. And 5 plus 1 is 6. So on the next one, we have f of x equals 7. So we have to find our equation with f of x, which is 4x minus 1. So we know that we're replacing this f of x with 7 and bringing down the rest of our expression, 4x minus 1. So in order to solve this, you add the 1 on both sides, and we're left with 8 equals 4x. Divide by 4, and x equals 8 divided by 4 is 2. So then it says f of x equals negative 5. So we're replacing the f of x in our equation with negative 5. And solve. So add 1 on both sides. Negative 5 plus 1 is negative 4 equals 4x. Divide to get rid of x's coefficient, and x equals negative 1. The last one is having us multiply h of x and j of x. So when we look back at our equations, we have h of x is equal to negative 3. So we have negative 3. We're going to multiply that by j of x. J of x is represented by negative 3x plus 5. So negative 3x plus 5. So when we multiply these, because we have a monomial multiplied by a binomial, we can just distribute. So negative 3 times negative 3x is positive 9x. Negative 3 times positive 5 is negative 15. Jumping over to the second page, it says use the graph to answer the following questions. Where does f of x equal g of x? So when we look, we try to figure out when are they the same, and it's where they intersect. So the ordered pair for where they intersect is 2, 5. So they intersect where x equals 2, and you could also put the ordered pair. So 2, 5, or x equals 2. You may see it both ways. So when x is 2 or at the ordered pair, 2, 5. So it says, what is f of 4 plus g of 4? So we go to, remember the 4 is inside, so it's an x value of 4 because it's your inputs. So we go to 4 on the x-axis, trace it up to our lines, and the g value is 6. So I'm going to write that underneath g of 4. And the f of x value would be 7. So I wrote it under the f of 4. So 7 plus 6 is 13. So then it says, what is g of negative 2 minus f of negative 2? So I'm going to go ahead and bring down this minus sign, and then I'm going to find my values. So negative 2 is inside the parentheses, so it's my input values, which means it's the x's. So when I draw my lines, I see that f of x is 1, and g of negative 2. F of negative 2 is 1. G of negative 2 is 3. So 3 minus 1 is 2. And then it says, state the interval where g of x is greater than f of x. So I notice that from here, this end point, all the way to the point of intersection, g of x is the higher line on the graph. Therefore, it's greater than f of x. So we're going to round this and say from negative 6 all the way to 2. That is the interval where g of x is higher on the graph. From that point, they intersect, which means they're equal, and then f of x becomes the higher function. The f of x would be greater than g of x after 2. All right, it says use the graph to answer the following questions. Where is r of x greater than h of x? So if we look at our graph, we see r of x is greater in the beginning, all the way until this point of intersection over here at 23. So from 0 to 23. And I'm assuming this line stops at 0. It could go towards negative infinity without context or arrows on the graph. It's really hard to tell. So what is r of 1 minus h of 1? So when we draw our line at 1, be very careful. I did not even see our scale factor on the other one. It's not actually at 23. If we look closely at this, we have 0.5, 1, 1.5, 2, and 2.5. So this one is actually 2.3, 0.2 as the ordered pair. So that makes r of x greater from 0 to 2.3. My apologies. So what is r of 1 minus h of 1? So we go to our 1 as the x value because it's inside the parentheses, so it's an input value. And we have, there is our r of x, and our h of x is here. So this r of x is at 0.5, h of x is at 0.2. So when we write it directly underneath, we have 0.5 minus 0.2, which gives you 0.3. So it says, what is r of 0 plus h of 0? So when we go to 0 as your x value, because it's inside the parentheses, so it's your input values, r of 0 is up here at 1 plus h of 0 is down here at 0.2. So 1 plus 0.2 is 1.02, and that's your r of 0 plus h of 0. So in our next section, it says, how do you know if something is a function or not? Explain for each of the following examples. When we look at this table, the number of gumballs versus the cost. So our x values are not repeating, and they won't repeat because the cost for gumballs is not going to be two different costs for the same number of gumballs. So we have an x value 5, x value 10, x value 15, x value 20. So this is a function because the x values do not repeat. And looking at our rate of change, our change in y, over our change in x, and it's actually a linear function on top of that. So then when we look at the next problem, the scenario, it says Susan put exactly $5 a week into her piggy bank. She starts with 14 and wants to see how much she can save if she doesn't ever spend it. So this one also is a function. If we wrote it as an equation, it would be y equals her rate of change is that $5 per week that she's plugging into her account, and she starts with $14. So again, this is another linear function. Your x values are not going to repeat. The weeks will not repeat. So on the next one, we have a mapping. So on this mapping, we look and we see that the x value 1 goes with 5. So that's an ordered pair 1, 5. 0 goes to 3. Ordered pair 0, 3. 1, 5. 2, 11. 3, 21. The x values do not repeat, so therefore this is a function. And then the graph. This graph is also a function. It passes the vertical line test, which means that the x values do not repeat. So passes the vertical line test, the VLT. So if we look at these, It says find the domain and range for the following. Be sure to watch the brackets and parentheses. So for the first one, this is a mapping. So we're given a list of ordered pairs in a mapping. So when you're given your list of ordered pairs, it is safe to assume that it is discrete. So your domain, your first ordered pair is 1, 2. The domain is the x values, the range is the y values. So 1, 2. 1 goes to the domain because it's x, 2 goes to the range because it's y. Your next ordered pair is 4, 5, and 4, negative 5. So we have 4, I always put the smaller y value first, and then 4, 5 is the larger y value. So then we have 2, 0, 2, 0. And those are all of the ordered pairs that make up that mapping. Now, because that 4 repeats, this is also not a function, which is me doing a little extra, but it's good to see an example that's not. So the domain on this one, remember domain is the x value, so how far to the left and how far to the right. So the leftmost point on the circle is right here. The x value of that ordered pair is negative 1, 0. The x value of that ordered pair is negative 1, so that's how far left. The farthest right is right here at 5, 0. The x value in that ordered pair is 5, so your domain is from negative 1 to 5. The range is the lowest to the highest because it's your y values. So this ordered pair is 2, negative 3. The y value is negative 3. This one is 2, positive 3. The y value is positive 3. So your range goes from negative 3 to positive 3. The next one, domain. So remember, it's easiest if you mark your ordered pairs. So this one is 1, 3, and it's the farthest left point, and the farthest right point is 5, 0. So domain is your x values. The x values in those two ordered pairs are 1 and 5. So 1, 5 is your domain, because the farthest left it goes is to 1, farthest right it goes is to 5. And then we have the range, which is your y values. This is also the lowest and highest points. So when we look at the y values of the lowest point, it's at 0. And the y value of the highest point is 3. So your range is from 0 to 3. The distance a runner runs per day versus the time spent running. So this is a linear function, more than likely, but we don't have any numbers. So this is all about the context, the words associated with the domain and range. So we're looking at a distance a runner runs per day versus the time spent running. So what we have is the distance depends on the time. So the more time you spend running, the further distance you'll make it. So your distance depends on how much time you've been running. So distance is your dependent, which is your range, and the time is your domain. Last one is this one. So first thing I noticed is that there are arrows on each end of this function. So our domain, how far to the left is it going to go? There's an arrow, so it's negative infinity, because remember, to the left is your negative numbers. How far to the right does it go? On the right side, there's another arrow, and to the right is the positive numbers. Your range values, how low? So the lowest point on this is right here. And we're talking about the y values. So the lowest y value is -1, and because there's arrows pointing upwards, it never stops going to those positive y values. So positive infinity. And that -1, because it stops there, should have been in a hard bracket. We always use parentheses with infinity because you approach infinity. You don't ever reach infinity. And the last big section, it says swine flu is attacking Porkopolis. The function below determines how many people have swine flu, where t equals time in days, and s equals the number of people in thousands. So s of 4. So remember, when it's inside the parentheses, it's your input values. So we're looking at 9 times 4, our input is t, minus 4. So 9 times 4 is 36, minus 4 is 32. So what that means is 32,000 people. I'm jumping into answer point B. So 32,000 people have swine flu. At 4 days. Because remember, your T is the time in days, and the S is the number of people in thousands. So 32,000 people have the swine flu at 4 days. So then we have S of t equals 23. So this time we're replacing the S of t with 23, and we have 23 equals the rest of our expression, 9t minus 4. So to solve this, you add 4 on both sides, and we're left with 27 equals 9t. Divide by 9 to isolate the t, and t equals 3. So what does this mean in context? Our time is 3, so at 3 days, remember, S is the number of people in thousands that are sick. So 23,000 people have swine flu. And the last bit is taking everything we know about a graph and identifying those key characteristics, those key features. The first thing is the domain. Remember, domain is your x values. It answers how far left and how far right. Because on the left side there's an arrow and the right side there's an arrow, we know it's going to be infinity in each direction. So to the left is your negative infinity. To the right is positive infinity. And we use parentheses because you never reach infinity. You can't stop there. You just approach it. So then we have the range, which answers how low to how high. So those are our y values. So how low? We're looking at negative infinity because down is where all the negatives are. And then how high? This is your highest point. And the y value associated with that is 7. And because that is a ordered pair on this function and it stops at 7, we use the hard bracket. So your x-intercepts. I'm going to zoom in for this one so it's a little more clear. So I see that it crosses the x-axis right here, and that is -3.50. I also see that it crosses it right here at 0, 0, and again at 4.50. Remember, if it's the x-intercept, the x value has the number and the y value is 0. So for our x-intercepts, we have -3.5. I need to zoom in a little. So we have -3.5, 0, 0, 0, and +4.50. The y-intercepts is where your line crosses the y-axis, which only happens in one place, at the origin, which is 0, 0. So our next question is asking about increasing. So I like to highlight on the graph just to make sure I can see everything very clearly. So we know at the very beginning, tracing this line from left to right, it's increasing. And then it starts to decrease. And then it increases again. And then it decreases again. So I also like to label each of the ordered pairs or really emphasize the arrows for these turning points. So this turning point right here is at approximately negative 2.5, 3, I'm going to call it. So negative 2.53. We already have the next turning point labeled at 0, 0. The following one is up here at 3.57. And then I also want to emphasize this arrow. So remember, your intervals are the x values. You always look at the x values for interval of increase, decrease, and constant. So for interval of increase, I know because this arrow, it's going to negative infinity. So my x value would be negative infinity, and then the x value where it stops increasing is negative 2.5. I also see that I marked it green for increase in this section. So the x value in the starting ordered pair is 0. The x value in the ending ordered pair is 3.5. So those are the two ordered pairs where it's increasing. So decreasing, we're still talking about the x values. So when we look at the x value at the point where it starts to decrease, and the x value where it stops decreasing, we have our interval from negative 2.5 to 0. This line is decreasing. So then we have one more section where it is decreasing, and that section starts at an x value of 3.5, and it ends with this arrow, which lets us know it goes to infinity. And that arrow is pointing to the right, so it's a positive infinity. So is this a function? Yes, because it passes the vertical line test, which means the x values do not repeat. Now, does it have any flat sections with a slope of 0, those constant values that are neither increasing nor decreasing? No, so we write none. For end behavior, remember that when the x values are negative, when you're going on the x-axis towards negative infinity, you're going to the left. When you're on the x-axis and you're going towards the positive infinity, you're going right. So when we look at the left half of this graph, we see that that arrow is pointing down. So I'm going to write my words here first. And then on the right side of the graph, that other arrow is also pointing down. So the ends of my graph are both pointing down. So down is where all of your negative numbers are, and since it's an arrow, it's infinity. And again, down is where your negative numbers are. It's an arrow, so it's infinity. So both as x approaches negative infinity, your y value is also approaching negative infinity. That means on the left side, the arrow is pointing down. And then as x approaches positive infinity, y is approaching negative infinity, which means on the right side of the graph, there is an arrow pointing down towards all the negatives. All right, our maximums. So we have the highest point. Is there a singular highest point on this graph? Yes. Where is it? At 3.57. Is there another high point that's not the highest point? Yes, we have another peak at negative 2.53. So absolute minimum. This goes down to infinity. So there is no singular lowest point because you can never reach infinity. And then a relative minimum. So is there another valley floor that you reach, a turning point going down? Yes, at 0, 0.